Okay. So I want to talk about before we get into the Grasshopper workshop, how we think about using Grasshopper, right? So Grasshopper is not something we just use for the sake of using, otherwise that's pointless. So it's something we use as a tool. So the comments early on from, I think, Tazeen are kind of very important. Yeah. So developing a spatial strategy. What is it, and how to use them for design? Yeah. So this is something I wrote down in terms of the steps or components of a spatial strategy, right? A spatial strategy is not something that you just come up with to develop an interesting form. And it's not something, it's basically a logic or an algorithm, yeah? So an algorithm does not necessarily mean computational code. An algorithm, in its broad sense, is a set of instructions or a set of logical steps, yeah? So this is what the spatial strategy is about. So the first component of the spatial strategy is the theoretical framework. What perspective, yeah? What perspective are you bringing, and how are you thinking about the problem that you have, yeah? So our problem is a design problem. So a perspective and kind of a particular view on a problem might be theories that we cover in CPU Breakfast. You need to all read the CPU Breakfast papers. I'm hoping you're keeping up to date with them. I think I've uploaded them to Moodle, so you should all have access to them. There might be a few not there yet, but I'll upload them as well. But they're very important in terms of how you tackle the problem you have, yeah? And of course, they have to be justified. So why are you using this theoretical framework? And the justification can be because you're thinking about this problem in this way because of a brief, yeah? Or because it gives you a design opportunity that other theoretical frameworks don't. Are we recording this? I just remembered that way. Is this being recorded? Let me just check. Oh yeah, the recording is started. Okay, thank you whoever started that. I completely forgot. Okay, so the second point, the second component is the translation of the theoretical framework into an abstract generative spatial logic. Okay, so the word spatial there is can be misleading. So if we ignore that, it will be an abstract generative logic. Yeah. And basically what this means is you have a specific context and you have a specific approach and you have a specific theoretical framework. And with this, you come up with an abstract way of thinking about the design problem that you have, yeah? So you communicate this through generative diagrams. Now, if I go to the second page, you can see an example of a generative diagram or a spatial strategy here, yeah? And this is thinking about the space, programs, and flows between them, yeah? And this is a very famous project, so Yokohama project, Foreign Office Architects, you should look it up. I think it was built in the 90s. But you see here, this is really the logic that the projects gets generated through. Yeah? So nothing spatial here in terms of where things go, but rather a relationship between things. Yeah. So you figuring out how you want to solve the design problem in an abstract way, not specifically related to your the space on your site. Yeah. So abstract in a way that you can describe what your design approach is. Yeah. So here we can see they're thinking about flows and how a ferry comes into deck, and the whole process of it to go to the city, and how different flows feed into different parts of the project. Yeah. So this will be an example of a generative spatial generative diagram. Yeah. So you use this to generate your building, and of a spatial strategy. So it's an abstract spatial strategy. Yeah. Okay, so this is the second one. So you take a theory, so in this case it was theories of flows, yeah, and they translate it into a theoretical framework in an abstract way. The third one is the parameter identification. So point 2 and 3 go hand in hand. So you define what are the things that you're tackling, yeah. So and concept relationships interaction. Yeah? So this, you won't find a theory that tells you this is exactly what you need to think about and this is how you think about it. So it requires interpretation from you. And then you going into the other steps. So that's third step. Fourth step is develop into an algorithm. So I've marked this with 2 stars here. So for design, meaning sequence of decisions, not necessarily computer script. So think of it as a logic for you to kind of generate your project in terms of the design. Yeah. So what are the sequences? This goes here, this goes here, this goes here. These are the relationships. And then through this spatial diagram that I've generative diagram that I've designed, I can generate the building through my thinking in that way. Yeah. So here the algorithm becomes a way, if we're talking about a computer algorithm, it becomes a way for us to generate our project through our own thinking and through our own design of the spatial strategy. Yeah. And this is very unique because you can iterate. Up here, number 5. So iterate, test, and tweak. Because you have an abstract logic of organizing space, you can actually, so as we see here, once you change something's position, yeah, in an example of a computer algorithm, everything reacts to it because it's bounded by these relationships that you've defined. Yeah, and this is where you can test your spatial strategy. What happens if I put these arrangements in this way or that way, and how that works. Yeah, and I can iterate, and then through this testing, I can actually go back to my this one here, parameter identification and concept relationships, and tweak it. And then number 6 is the performance test, measuring the success. Yeah. So performance test doesn't necessarily mean a number here. It can be qualitative, so you assessing the design and how it works, and you testing the output of your spatial strategy. Yeah. So again, this is the generative tool, and I'll show you the. Actually, never mind now. But you can look up this Yokohama project, and then kind of look at how this diagram was actually the whole project was based on this diagram. Yeah. Another example of a spatial strategy here. So not site specific. Well, it is site specific in the sense that the spatial strategy was designed for the particular context and site, but not in terms of the positions of things in space on the site. Yeah. So again, another good example to look up, Open Plan Office. Yeah. And here again, there's also flows and strength of interactions, and not just like lines connecting different things together. Yeah. Okay, so I want to cover 2 examples. The first one is just something that I, not a specific kind of example, it's just one of the thoughts I had when I made this presentation yesterday. And the second example is one of my old projects, when I was young and in CPU, years back now, and how I developed kind of an approach to kind of test these different spatial strategies. Yeah. So this is example 1. A city is not a tree. Okay, so this is a theoretical framework. You're all familiar with it. We had it presented in CPU breakfast, I think by Michel and Tazine. The idea of this is, of course, the theory of lattice and semi-lattice, how cities designed in a kind of tree structure meant that the system was stretched and not very resilient when, the cities designed in semi-lattice structures like New York, etc., were a lot more resilient and were a lot more vibrant. Yeah. So this is one approach, and the theory itself provides you with a way of developing your own spatial strategy. So on the left, you can see an example of a semi-lattice structure, and you can see here a network, an abstract network diagram explaining the relationships between the different sublattices here. Yeah, and you can see things connect as a network. Yeah. And not as a tree that just has one point where everything gets generated. Whereas here you can see this is supposed to be the wrong way of doing things is doing it through a tree structure. Yeah. So branching out here, and this is designing in a way where elements interact with each other. So this system is a lot more resilient, a lot more capable of change than this one over here. So this is the translation of the theoretical framework into an abstract generative logic. I think a city as a tree is the theoretical framework that really provides you with the way of conceptualizing the generative the logic already. Yeah, other theories might not necessarily do it. I mean, all the theories are different and they all need a different process, but this is one example that I thought of yesterday. Okay, so in terms of let me move this here. In terms of an example, so when it comes to the scripting of it in Grasshopper, this is where we need to start to think about, okay, how can I use this as a tool to develop my spatial strategy as a computer algorithm and test it out, right? And this is where I need to really look into the plugins of Grasshopper, what the plugins offer, yeah, and what you can do with them. And if you can't find a plugin, develop something yourself or choose a different theory. Yeah. So at this stage, we're not really in 6th year. What you'll be doing is you'll be developing your own tools completely. Yeah. In 5th year, we're asking you to look up plugins, and they'll help you. They'll help you design your spatial strategy, yeah, and realize it. So this is one tool in Grasshopper called Magnetize. It's a way of generating abstract floor plans. So, the idea is not to generate a complete building in Grasshopper, right? That's not what we want you to do. We want you to develop it to test an idea, develop something to test an idea. So in your submission, it can be as abstract as this, as you can see on the left. Yeah. It doesn't necessarily need to see walls and all that kind of stuff. But I want to see that you've developed a spatial strategy and you're testing it. And this then you can translate into a building through a manual process. You taking this and actually rationalizing it and making it into a building. That's fine. But here you can see you can develop this is the, by the way, Grasshopper nodes, but they're in a different way just because this plugin is a bit different. Yeah. But this is the idea. Okay. So that's the first example. Before I go into the second example, I'm just wondering if anyone has any quick questions. Otherwise, we'll move on. So are these steps here that I've identified clear? And do they make sense? Is anything not clear?
Yeah, makes sense so far.
Good. Okay, so example 2. Again, a theory presented today, field conditions by Stan Allen. We mentioned earlier, of course, that this theory is very helpful because it gives you two perspectives. Most theories give you two ways of doing things, so to analyze and to generate. Field conditions, definitely one of them. Field theory, spatial strategy. So the idea of moise. The moise is actually a good way of developing your spatial strategy because it explicitly talks about geometry. Yeah, and that's what you're doing when you're thinking about your spatial strategy. It's about geometry and developing the thinking about your design in ways and relationships. Yeah, so it talks about how combining different fields together produce something different here. So this can be fields in terms of the existing structure of a building. It can be more ambient stuff. It can be lights. It can be about air. It can be so many different things, fields. Yeah, and it's so open, and really it's a matter of your interpretation. How do you want to interpret this theory and take it into the architectural realm and this spatial strategy realm? Yeah. So again, read that if you haven't already to kind of start thinking about that. So this is where I talk about one of my old projects when I was a 6th year. So translation of theoretical framework into abstract generative spatial logic. So with this approach, what I did then was think about different programs. So at the time we were working in a brief situated in 2050. So 30 years from now, so it's very futuristic. So thinking about how things adapt and change over time is very important. Yeah. So with this theoretical framework, I started looking at the field conditions within my site and within my abstract structure and how I can organize spaces. Yeah, and how they can change over time. So this is thinking about fields in terms of light, circulation, and noise, the different requirements of different parameters and the relationships, the different requirements of different programs and spaces and the relationships between them. Yeah. So here are fields, for example, a lecture theater will need to be in a place where it doesn't need light. That's not a priority, but noise is a very important aspect, right? So thinking about how these different conditions within my volume or within my building affect where I should place certain programs. Yeah, and then you develop the spatial strategy. So here, the spatial strategy is about arranging certain programs in certain places based on their relationships to other programs, as well as the relationships to the existing conditions that are offered on the site. Yeah. So then you develop the script, computer script in Grasshopper, and then you test it and tweak it to whatever suits you. Yeah, so testing and tweak. What happens if you have this arrangement or that arrangement, and how does it work? As you can see here, these are the different performance criteria and what kind of spatial aggregations and arrangements can I make through this. So you can see once you change your parameters or your requirements, your building adapts and changes to suit. Yeah, so you can see it's not a complete building. This is not, I'm not taking this and saying, okay, let's go and build it. I'm saying this is a way for me to think about how I want to organize space. I've developed my thinking into a way where I can test, yeah, and the numbers can just get crunched by the computer, but it's all my thinking, it's all where I want to place things, and I'm just testing it. All I'm using it for is a tool to test and iterate through my approaches.